All right. Can anybody hear me? Testing. Okay. All right. Welcome everyone to the CSS and VGDC workshop. This is going to be a Unity workshop hosted by Shayan and Amitoz. We did, however, run into some technical difficulties, unfortunately, and Shayan cannot talk as his mic can't be picked up for some reason. We've been trying to debug it for like the past 30 minutes and we've gotten nowhere. So Shayan is most likely just going to be typing inside the chat. Shayan, if you can just say hi to let people know who you are, that would be great. And then Amitoz is going to be the one that's going to be talking. For questions, there are actually, let me add Amitoz too.
So, how is everyone
That's
today?
Amitoz right there. Yes, so Amitoz is going to be the one that's going to be talking. He's going to be the one that's going to be walking through everything. And then Shayan is just going to be on the side too, typing. For questions, I think Amitoz, you want them to be at the end, right?
Yeah, unless it's, something pertaining to the code itself.
Yeah. Okay, so I'll just do a brief introduction. My name is Usman Faruqi. I am head of events and also the president of VGDC. We are a game design workshop, not workshop, my bad. We are a game design club where you can join and talk to people about designing games. You can make projects that revolve around games, all sorts of stuff. This is our first workshop, our first event in a year. I think we had our last one a while ago. And then, yeah, so today is just going to be a starter off where these guys are going to basically explain to you what Unity is, setting it up, think even a game involved, might make a game or something. That's up to them. I'm just going to let them take over now. So, Amitoz, I'm going to share your stream. I think this one is you.
Yep, that's me. All right. Well, as you might know, games are created using game engines, and the Unity game engine is a pretty popular platform. So, Unity is a game engine both 3D and 2D that can be used on all platforms. You can use Unity to make games, apps, and almost anything really, even animations. I've seen a few pretty good Unity animations. There is unlimited capability to Unity, and today we're going to show you the basics. So, I went to my Google and I've typed in Unity, and Amogus. we just get started with Unity. We're using we don't have to worry about teams. We're using the free personal version of Unity. And if you click this, you can download for the Windows, and it'll give you the exe. And just press yes to all the things that it asks for. And well, I've got it downloaded already, so I don't have to install it. And once it's done, it'll open two things. They'll be up here. We've got Unity and Unity Hub. Unity Hub is this thing right here, this application, and it's just where you start installing your projects. And so we can start with a new project. What we're gonna make is Pong. Let me open it up here. A pretty basic Pong. We want to make a game like this. And, first marketable game in the world. And that's what we'll be making today. So we open our Unity, and Unity has a lot of options. It even has VR, AR, and, all of the options. It also has learning samples. But today we're just going to stick with 2D so that we can make the Pong, because Pong's a 2D game. Oops, I didn't name it. Oh well, whatever. So Unity will take a second to open. Unity is like 4 gigabytes, right? Something that size. All right, we've got Unity up and running, and we have our project. Now Unity gives you a blank canvas off the bat, and this is what our game looks like right now. Just one big blue screen. If we want to go to our scene, we can see that Unity provides us a grid system, which we can use, and the camera, and other games can adjust these things, get them moving to follow the player or to do the things. But for us, Pong, the camera will stay right there. So let's go to back. We got over here Inspector, which allows us to see the components of the main camera. And over here we've got the position, rotation, scale, the position of the camera, which is the whole screen, and we have the camera settings. For now, we'll just use the color, and we want to make it black. Classic Pong. We don't have to worry about the rest of this. Over here in our hierarchy, we have our game objects. Here is where here's where it'll list the objects of the game, such as player, enemies. If you've got a ground, it'll put it there. And down here we have our project folders. As you see, this is the sample scene that Unity hands us right off the bat. Just a whole lot of nothing right now. And this is pretty important because this is where you would place most of your assets. If you were to make a game a bit more complex than Pong, you would be using images or sprites, so you'd be storing them in here in your assets. For now, let's start with making our objects. Now Unity has a pretty wide selection, and it's a little overwhelming at the start. So we want to make an object. What does Pong have? It has our ball, and it has our 2 paddles, right? And we want our paddles here, and the ball in the middle. So let's create a 2D object. We'll go to sprites, and we'll choose a square. And let's call the square ball. Now we've got ball, and here is our ball components. And as you see, it's on the screen. Nice little square. It's a little big for a ball, so let's scale it down a bit. 0.25 for size, and that seems like a pretty good size. Shayan, can you hear me? All right, you're just muted. Okay. So our ball's in the middle, position 0, 0, 0, as according to the grid. On the grid, you can see that the ball is here. It's covered by the camera icon. And we can change the color of the ball as well. Let's make it green, just for the heck of it. Position 0, 0, 0, rotation 0, 0, 0, scale 0, 0.25, 0.25, and C1. C is our rotation. Let's make our 2D object, let's make our paddles. So we'll do the same thing, square. Let's call this square. We can name it here, up here too, or we can rename it here. Player paddle. And we click on it. We'll put it at 0, 0 for now. And let's make it 0.25 width. And its height, let's make it 1.5. Pretty good size. And now we want to move it to the left. That's in the negative x direction. So we'll give it a value of, we can look at our scene. We got the grid system here, -1, 2, 3, 4, 5, 6, 7, 8. -8. And now what we can do is we can copy and paste our player paddle for our paddle. And it's just pasted right on top of it. So let's move that to the right side of the screen, +8. Now we've got a pretty good scene going on here. But this is all just visual. Now we got to add our physics and our collision. So let's start with the ball. We'll go down here, and if you were making a video game from scratch, or if you were to just go into a program and start bashing the code by yourself, you would have to make a physics system, make sure that gravity is affecting the ball, move it by pixels, all that nonsense. But for Unity, they've already got you, fam. They've already got something called rigid body. And this is our physics engine. This is what will simulate the physics on our objects. So we got a 2D game, so we'll choose rigid body 2D. And now our ball has a rigid body. And we'll also give it box collider 2D. And this will give the box collider. We can look at it. It'll cover this. It'll automatically scale to the size that we've given. And this is what the game assigns as the box collider. So what does the box collider do? Whenever something interacts with something, it makes sure it notifies the engine. So if you want things to, collide with each other, or if you want a player to stand up on a platform, you need to make sure both the player and the box collider has the platform has box collider, so that they can interact and know that the player doesn't fall down. It stands up top of the platform. Right now, our rigid body 2D, we have a couple of settings. The mass of the ball is 1. It has a linear drag of 0. It has an angular drag of 0.05, and it has a gravity of 1. As you might imagine, we don't really want gravity, because if we were to run it, our box collider, our ball just falls off the map. So we want to get rid of gravity, and also angular drag. We don't want our ball slowing down. A linear drag as well. Just keep it 0, 0, 0 with a mass of 1. And that's all we need to do for our ball. So let's go to our player paddle. Let's also give it rigid body 2D. For the player paddle, we'll give it a mass of 0.5 and a linear drag of 2 and a gravity of 0, of course. What does the linear drag do? It essentially applies friction to our paddle. So later on, you'll see that when we interact with our paddle, use the arrow keys to make it go up and down, it'll slow down after you've let go of your arrow keys. And we give it a mass of 0.5 just so that it's nice and light. We'll give it box collider 2D and just keep that the same. For the computer paddle, we'll do the exact same thing. And now we've given our ball, our player paddle, and our computer paddle physics and box colliders. So now what we want to do is we want to put walls around our game, so that if the ball were to interact with the wall, it wouldn't just fly off into the void. It'll stop and it'll bounce. So what we're going to do is we're going to create an empty game object. Let's call this top wall. Put it at 0, 0, 0. And if you see, it's just one very small square. Can't really see. So let's increase its X scale. Let's make it 10. Okay, you can't see anything because I didn't add the box collider. There we go. Now you can see it's got a width. Now 10's not big enough. Let's make it 20. And we don't want it in the middle of the screen. We want it up here, so we'll move it up. There's a 5. There. We'll move it up 5.5. And now we can just copy, paste, call this one bottom wall, and make the Y position negative 5.5. Let's create our left and right wall. So start with the left wall. And let's give it the box collider 2D. And we'll make it wide and 10 high, 11 high. And we'll move it in the X direction by 9.5. Moved it that way. Yep. Well, since this is the left wall, we want it on the left side, so negative 9.5. And let's just copy paste that. Right wall. And make it positive 9.5. So now we've got all the walls. Nice and easy. So now at this point, we get to the fun part, the coding. Let's go. So let's just make a folder for our scripts, call it scripts. And we'll start with the player paddle. Am I going too fast? Left wall to the left wall position again. So we've got let's go to scene. We made it negative 9.5. We moved it from this part to the negative 9.5 on the grid. Just moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 9.5, right there. That's where we centered it. All right, I'll just give you guys a minute to just give me a minute, actually. Let me just see. So what we do now is we get to our scripts. Our player paddles, they're not doing much right now. They're just sort of existing with their physics and the box collider. Now what we want to do is we want to add functions to them. Code. Make sure that we can manipulate what they're doing. So we'll make a C# script and we'll call it paddle. And we'll make two more C# scripts, one for each of the player for each of the paddle. One for the player paddle, one for the computer paddle. So we'll create a C# script, call this one the player paddle. And we'll create another C# script, call this one computer paddle. So let's start with our paddle. Why did we make this function? So that we can, since our computer paddle and our player paddle are pretty similar, we can just put some of the similar code in the paddle and then call it, ring it up, and bring it to the player paddle and computer paddle later on. Yeah, I trust the authors. So here we've got, I opened it on VS Code, Visual Studio Code, and Unity gives you a simple script to start with. Now, for now, we don't need the systems.collections. We won't be using it in this tutorial. And let's just get rid of these two as well, so that we just start fresh. So we've got paddle, and for our paddle, we want to call the physics engine, rigid body it's called. Make sure that our paddle has, because we're going to manipulate the physics, we want to call it. So what we do is we say protected rigid body 2D underscore rigid body semicolon. The protected part here will allow the computer paddle and the player paddle to call the rigid body. So we don't have to call the physics engine for the computer paddle and the player paddle. And we'll just set, this function will make sure that only the paddle, only when it's called, when paddle itself is called, is it being ran. So let's start off with awake, private void awake, and we'll just give, and this is where we'll call our rigid body and assign it to a variable. And that's all we're going to do with awake for now. Yeah. Okay. Yeah. Okay. So what does awake do? Awake is what we call whenever the script is run. So this is what we use for initialization. So whenever this script is first run, it'll go to awake, and then it'll assign rigid body this to the rigid body 2D. So let's put that to the side for now, and let's work on Yeah, hopefully that doesn't cause any problems. That's where we see our errors. Let me save. Hopefully that doesn't cause any problems. Let's go to our player paddle. Once again, Unity gives us the beginning stuff, good stuff. Now, what we want to do for our player paddle is we want to have the player control it, right? We want to use our arrow keys or our WS up and down. So what we want to do is we want to create a function private void update. So this function will run the code every time Unity updates, making sure that everything, whenever the game is running, that this function is also running with it. So for the update, first we want to, before we get into making our up arrows and down arrows, we want to get our vectors. So we say private vector2 underscore direction, and this will let us assign directions and vectors to our player paddle. Where did we get this thing? This is from our rigid body 2D in our player paddle. So we might want to call that. So we got our public class player paddle. We say paddle. And now player paddle is connected to paddle. And the benefits of rigid body is moved forward to our player paddle, and therefore we can call vector 2. So we go to our update, private void update, yep, and we say if input dot get key apostrophe brackets key capital code dot w line, and also we want to put our arrow key input dot get key code dot down arrow, and now whenever our W is pressed and whenever our down arrow is pressed, sorry, not down arrow, up arrow, up arrow, up arrow. Whenever our W is pressed and whenever our up arrow is pressed, that will allow us to call the if function, and make sure you guys are using your capitalization. If you don't, your code will run off the rails. And all we do is we say direction is equal to vector2 dot up, colon. And that'll give us a vector of up, and that's just assigns the direction. And now we say if, let me just copy that. Control C, Control V, capital S, and capital E down arrow for our underscore direction equal to vector2 dot down, lowercase down in this case. And now whenever our key goes up, whenever we press a W key or arrow key, it goes up. Whenever we press our S key and our down key, it goes down, points down at least. And else, just for funsies, underscore direction is equal to vector2 dot 0. Essentially, once you let go of the keys, it should be making 0 vectors and not keep on going. That's all we're going to do for the update. Now we're going to go to make a private, another function called fixed. So update is directly, whenever update is being called, it's related to the CPU, like frame rate. For fixed update, that just, it assigns it, a fixed up, it'll periodically update. And so the speed of the game isn't connected to our update. Usually you want to keep physics related things in the fixed update so that, things don't start falling faster than you're super fast because your CPU is really good. So we say if underscore direction dot square magnitude, SQR capital M magnitude is not equal to 0, then underscore rigid body dot add force underscore direction multiplied by using the star this dot speed apostrophe at the end, not apostrophe, semicolon. And now what this does is it takes our direction, whatever our direction is, and it multiplies it by this speed, which I forgot to do. It's in paddle. So let's hold our horses. What is the speed? I forgot to add speed to our paddle. So Unity, we just add public float speed. We go back to our paddle and we say public float speed is equal to 10.0 f float, just how C# is. And so whenever our player paddle adds a force, it'll take the direction up or down and it'll multiply it by the speed. Our speed is 10 float right now, and that'll be which way it goes. Now, if we file save all and go to our Unity, shoot. As you see, it's given me an error. Very nice computer. Asset scripts player paddle.cs line 15, I think that is. Oh, sorry, not 0. The word 0. The 0. The word 0. And now it'll load the scripts, and hopefully now it'll. Yep, okay. So it let me run the game scene, but our player paddle still needs the script. So in order to add the script to the object, we can add it here in the add component. we can search for it. Player paddle. Or we can drag it to our object, player paddle. As you see, we don't need two of them. So now if we run it, okay, it moved. Why did it keep going? Okay, only the down arrow is working right now. What did I do wrong? Hmm. Oh, else if. Let's see if that was it. There we go. Now we see our player is going up and it's going down, and once you let go, it stops. I'm not streaming? Shoot. Shoot. Okay. There we go. Sorry. I accidentally closed something. Looks like closed the stream. Okay, here's what we fixed. I forgot the else if. It needs to be all one else if statement. If, else if, and else. And now it allows the player to go up, to go down, and to stop. As you might notice, it's got a little bit of an acceleration and deceleration. So once I let go, it keeps going for a little bit. That's because of our linear drag. That allows it to slow down and stop. So that's just a little bit of improvement of movement. Not really needed, but makes it more fun to play. So now we got the player paddle and our paddle. And we'll hold off for the computer paddle for now. Let's make sure our ball has a script. So I'll create a new script, C# script, call it ball. And let's open it in our VS Code. Once again, just get rid of everything. So our ball will have, what does the ball need? It needs a speed and it needs to start moving, right? So let's give it our speed right off the bat as a float. It needs to be high or else it won't go fast. And we need to call the rigid body. Rigid body 2D underscore rigid body. Also, you guys don't have to worry so much about this coding. We'll just give you guys the we'll give you the full code at the end. We'll post it. Can we post it in the chat? How many characters do we get in the chat? Shayan. We'll post it in our VGCD DC. Okay, the entire project will be on the GitHub, and you can see it there. And so we got a rigid body. Let's make a private function void awake. Now, what does the awake function do? It'll initialize the program. This will become initialized once the script runs. This thing will initialize, And what we're going to put in here, once again, just rigid body. I repeated that. Sorry about that. Body. Same. You know what? We can just copy paste it. Control C. Control V. Lazy. I'm lazy, I know. All right. Private void start. And what we're going to do, we won't do anything for that right now. We need to give a public void add starting force. This is just going to be our own function. It's nothing that Unity has any special attachments to. And what we want to do is we want to get the ball rolling, right? Get it moving. And so what we're going to do is we're going to assign it a random value left or right. So let's give it float x is equal to random dot value 0.5f question mark negative 1.0f dot 1.0f. So now what does this do? It essentially flips a coin, you know, and it says it'll be either going in the left direction or the right direction. And we want to do the same thing for our y coordinates, except for this one we'll do it a little different. Because if we were to just say, oh, it goes up or we go down, it'll get boring, right? It'll just go linearly on the just go one direction, and after a while that might get boring. So what we're going to do is we're going to say value. We'll also give it a coin flip 0.5f question mark, and we'll give it a random range between 1.0f negative 1.0f and negative 0.5f. Now what does that do? It'll take the coordinates, and I think this is the right side actually, and it'll say it'll go off some direction this way or this way. And we'll also, so that gives us one the top or the bottom, a little random line, and we want to give it random dot range negative 1.0f negative, sorry, this one will be positive 0.5f comma 1.0f. We want the bigger number on the right and the smaller number on the left. Negative 1 is technically smaller than negative 0.5, so keep that in mind. And now what we're going to do is we're just going to give the vector. I'm going to say vector 2 direction is equal to new 2 x comma y. And we'll give it underscore rigid body. We'll apply to the physics dot add force direction multiplied by this dot speed, ball speed. So now if we save that, we're almost done. For the ball, we say public void add force. It'll take vector 2 and force, vector 2 force. And we just say underscore rigid body dot add force. A bit redundant there, but yep, that's what we need to do. And did I declare vector 2? Yes. Oh, yeah. Okay, that'll give it a new vector. I think this is what we. So, well, we don't want to when our ball is moving around and we want to give it the direction of a new vector. This is what we say our vector direction will be for x and y. So for the player paddle, it's only up or down. So our vector 2 can be, up, or it can be vector 2 down. For this vector, we need 2D, right? It needs to go in on the graph, either up, down, and in like a line. So when we assign the xy direction to the vector 2, it needs to be new vector. And that was my error. Thank you for pointing that out. I needed a space there. So file, save all. And now we go to Unity. And there we go. Perfect. No errors. So we'll go to ball, add the script. So we go to add component, ball. And as you see right here, this is our speed. Same as this is right here. So if we wanted to change the speed of the ball, we wouldn't have to, go to the script. We can just change it in here. So if we hit run, oh, I forgot something. I forgot to add it to start. We need to add starting force to start. Ball rolling for real. And we just say file, save all. So we got all our functions, right? And this function here for the add force of the rigid body. And once the game starts, it'll add the starting force. So now if we run it, oop, the ball moved. Yep, there goes the ball. Didn't bounce off. We'll change that in just a bit, but it goes in a random direction every time. Perfect, either up or down, and it's slightly changes it, so it's not so repetitive. And we can change the speed. Let's say we want it really slow with a speed of 50. And as you see, it is nailing along there. 200, let's keep it at 200. And yeah, that's our ball. So what we want to do now is, as you might have noticed, our ball doesn't bounce. So we got to change that. Now, Unity is very fun because they have it built in already. So we'll just go to our assets down here. And let's see, what was it? Create physical material. And we'll call this bouncy. want to do this. So we want no friction and all bounciness. And this is a material. So this is what we'll put in our ball, in our box collider. I think it's the rigid body material. So should be here. We can just drag it. Okay. So sorry, I told you to do it wrong. We don't want to go to that. We want to go to create 2D and physical material 2D. So we don't want regular materials 3D. We want it only on the 2D. So we'll just say physical material 2D. And we don't want 3D materials interacting in a 2D physics. So we'll say physics material 2D. And there, yeah, that's the one that I was looking for. So zero friction, 100% bounciness at 1. And now we just go to our ball, and we can just add it from here. Let me rename that bouncy. There we go. And for our ball, we can just drag it in. And now our ball bounces. Boing-a-loing. Perfect. Oh, okay. As you saw, it sort of bounced off our paddle. Our paddle got moved around. That's an oversight on my part because it needs to be constrained. We want our paddle going only up or only going down. We don't want it physically being moved left or right. And if things are hitting it, it'll move. So we'll stop the play, because if you change things while you're in the play function, it won't save. So we'll go to our player paddle, and we'll say freeze the X position and freeze the Z position. Now it'll keep it right there. It won't let it move left or right, and it'll prevent it from rotating. So let's also go and do freeze position. It's underneath the rigid body. 2D under constraints. It'll be like this. And freeze position X, freeze position Z. And for our ball, we'll freeze position Z. It doesn't really matter. It'll just prevent the ball from spinning. And now it bounces nice and easy, and it doesn't move. So now, next thing we want to do is we got our player moving, we got our ball bouncing, but now we want our computer to become an AI. So this is pretty simple. We'll just open our computer script. Remove these two. And get rid of everything. So we got our computer. And what we want our paddle to do is we want it, whenever the ball is heading towards the paddle, we want the paddle to move up or down according to the ball. So in order to do that, we need to make sure that the computer paddle make sure that it's not mono behavior, it's inheriting from paddle. And what we're going to do is, when we call a rigid body we'll call the rigid body 2D of the ball, our ball. Now what this allows us to do is it allows the computer to know where the ball is, which we'll implement in just a second. And the computer will essentially be able to see the ball, be able to track it. So we'll say private void fixed update. We want a fixed update because we don't want the computer acting faster than regular fixed update intervals. If this dot ball dot position dot y is greater than this dot transform dot position dot y, and what we're going to do is we're going to say underscore rigid body dot add force vector 2 with capital V multiplied by this dot speed. Now what this does is if the ball is above the current position, then we'll add the force to our computer paddle, moving it up to meet the ball. And now we do it for in case the ball is below. So let's just copy paste that. Else if below this transfer position, yep. And then we say vector 2 dot down. Go down. Vector 2 dot up makes it go up. Sorry. And then else. And then let's make it for the x value too, right? Actually, that's it. Okay. Oh, I forgot. So, if the ball is above, it moves up. If it's below, it moves down. But this is kind of unfair. The computer's tracking it constantly. So what we want to do is we'll say that if the ball is heading towards the computer, it'll change. It'll change its position. So put this if statement inside an if statement. We'll say if this dot ball dot velocity dot x, the x-axis, greater than 0.0 f, then just put this in there. It'll look a little neater. Else we'll just say, we'll copy this segment again. Whenever the ball is not heading towards the computer, we want our computer to be in the middle of the screen. So we'll just, instead of saying the ball position, we'll say 0. If 0 is less than this, then it'll move up. .0.f, and then if 0.0f, it'll move it down. This will let it get in the middle of the screen. So I think that's it for our paddle, computer paddle. Let's file save all. Fingers crossed, no crashes. Okay, that's not an error yet. So let's go to our computer paddle, and we'll put our computer paddle in, and that's the problem. Let's see. What did I mess up? Good Lord, hallelujah. What is wrong? Now would be a good time for any questions. Oh, I've completely forgotten about all of my apostrophe, all my semicolons. By the gods. There we go. I'll say whole. Rookie mistake. There we go. Now we've given our computer paddle code, and over here we see our computer paddle speed, and we need a ball to put in our computer paddle ball. Perfect. Yeah, I forgot my semicolons. All right, so now right now it can't do anything because it doesn't know where a ball is. We have to manually add that. So we're adding the ball object. We can drag it from our hierarchy and put it right in our box in our code. And now let's try to run it. And there we go. Our computer paddle is now working, and it's and it's going to the top of the screen whenever the ball's. Okay. All right, let's speed things up. We'll leave it like that. It's fine. So now we got our game running, and we want the ball to get faster every time it hits an object, like top wall, bottom wall, our paddles. We want the ball to get a little faster, so that we can win against our computer paddle. So what we'll do is we'll create C# script. Let's call this bouncy surface. Open it up. And just the usual. Remove this, remove that. And we'll just say public float ounce strength private void on collision. Enter 2D collision, 2D collision. A lot of collisions. Ball equal to collision dot game object dot get component ball, and if the ball is not equal to null, if it hits something, we say vector to normal is equal to collision dot get capital G contact 0 dot normal, and then we ball dot add force negative normal multiplied by this dot bounce strength. So let's save all. So remember, I sell it with semicolons. Save all, and now we go to it should be outside of our function. Should be inside. All rookie mistakes today. So now let's add this to our. Let's first add it to our player paddle just to test it out. We'll go here, add component, and let's give it a bounce strength of 100. So once it hits our player paddle, it should run away very fast. And I think that's a pretty fast speed change. Yeah, it's increasing speed a lot slower than I thought it would. So let's give it a speed increase of 100, 1,000. Wait, I shouldn't be adding it to the player paddle. I should be adding to the ball. Sure thing. Now remember, it's negative normal because it's going in the opposite direction. Let me make sure I did this right. Ball is equal to collision dot game object dot get component ball. If the ball is not, if the ball is hitting something, then we say vector to normal is equal to collision dot get contact 0 dot normal semicolon ball dot add force negative normal multiplied by, let's say multiplied by 2 multiplied by this bone strength. Maybe that'll make it run a little bit better. Yeah, I think it's speeding up, right? No, I don't think it's changing, is it? Do. Did I have to change something for the ball? Well, whatever. Let's just add it. Make it 10 for the top wall, for the bottom wall. Hopefully I'll fix it by the end. Computer paddle. Add component. Bounce strength 10. Yep. Yeah, the velocity is not changing. 1 second. Bouncy surface. This strength. Pop a void. On collision 2D. Ball. Yep, this is right. All right, we'll just ignore that for now. So now we got our game. It's pretty all right for now. What we want to do is we want to add a UI. So we'll go to UI text, and that'll give us a nice canvas. You can't really see it, but there's some, it says new text right next to the ball. Let's make it 0 and make it a much bigger font. And let's make it white. And make it, where'd it go? Oh yeah, sorry, overflow. Make these two settings overflow. Make the font size much bigger than that. Not that big, 180, there we go. Right align, 150, right align, so once we start typing in it, it'll go in the left direction. Perfect. Yeah. So yeah, if we had an issue earlier where we would be messing with the aspect ratio, just make sure it's at full HD, 1920 by 1080. Hopefully that'll work on your computer. So we got it. Let's move it to the left, top left position. -100. Position 500, and let's call it player score. And we'll just copy paste it right in the same spot and call this one computer score. And it'll be the same. It's right on top of it. So let's move it to, I think, just 0. 50. How about that? And let's negative 150. There we go. That's nice and aligned. So now we've got the score. Now we want to be able to change it around a bit, right? So it's not doing anything. It won't change. So we want to change it whenever it scores. So now here's for the long part. We'll make something called Game Manager. And that Game Manager, it's a changed icon because it's such a often used script that Unity just says, yeah, that looks, we'll change it for the fun of it. And we'll make another one called Scoring Zone. And if we open our Game Manager, since we're running low on time, I'm just gonna speed through it. Get rid of this. We'll be using, we'll use Unity. Using Unity. Engine.ui. Game manager non-behavior. We'll say public. Public, we'll call it our ball. Player paddle. We'll be calling all the stuff so that we can manipulate it. Public. Now here we'll be adjusting the public text. Player score text. I think that's what we called it. Player score. P player score text. It's hopefully I didn't need to change it. Public text computer score text. And we need private int underscore players score private int underscore computers, where we'll store our points. Public void player scores. When the player scores, we want to increase score by 1, right? And we want to say this dot player score text dot text is equal to underscore players. What is it? Player player score underscore player score dot to string, turning the integer to a string. And we'll do something in just a bit. Let's make our public void computer scores underscore computer score plus plus this dot compute underscore dot text is equal to underscore computer score dot to string. And now this will, whenever it This will, whenever this is called, it'll increase the score. We also want to some of private void reset round. So we want to make sure that when we score, it is, it'll reset everything. Set all the player paddles back to position, set the ball back to position. So we say this dot player paddle dot reset position. This will be the function that we'll call. We'll put the function in the computer paddle and the player paddle. And since we're resetting the ball, we want to give it a new add starting force. So we want to do it every time it scores. So we just say reset round. Now we got to add the reset position for our player paddle and our computer paddle, right? So we'll be putting it in the player paddle. So we'll go back to our paddle, player paddle. And actually, I think that's it. We'll go to paddle. And we'll say reset public void reset position underscore rigid body dot position is equal to new vector 2 underscore rigid body dot position x dot x, and we'll set it to 0.0 f. Yeah, I'm running out of time. Should I just post all the code? Just post it in the chat or something. Maybe in just the VGDC. Shayan, sorry. I'm talking to Shayan right now. Yeah.
Yeah, that works. You guys can do that, and then you can just end the stream off. The code will be on GitHub anyways for people to see.
Okay, let me just copy paste all the code because I messed up somewhere. Looks like it. Sorry for running out of time. Next time we'll make sure to. Next time we'll make sure to keep track of this stuff. Now we're just gonna let the computer score on us to make sure that everything's running fine. And it's not because we didn't assign left wall. So let's pause that. Left wall needs the scoring zone. Right wall also needs the scoring zone. Hopefully now it should. Okay, whatever. So sorry we couldn't finish the game in time. So if you want to if you want to export the game, we go to build settings. We unselect the sample screen and we add an open scene. I think that's just the open scene that we have. And we say we keep it all the same. We want to export it to PC. It's got all the options. We got web, iOS, PS5, even Android and Xbox One. We say build and run. I'll put it in a random folder on my desktop. And there you've got the game in your Unity. We'll give you the running code, that one that actually works. And if you have any questions, now's a good time to ask because we are out of time. So now if I were to go to I've got saved on this. No, I don't. Yep. Let's see. Yep, and here's the .exe. This is what you click to run it from your files. I hope you learned some fun stuff today. And consider joining the VGDC, our exquisite Discord server, to connect with more of people like us. And yeah.
Alrighty. Can you guys hear me still? Amitoz, can you hear me?
I can still hear you.
All right. Thank you, everyone, for coming on out and joining the Twitch stream. Thank you, Amitoz, for doing this, and Shayan, obviously. And Shayan, I know it must have been hard for you to be in the back, not being able to talk. But yeah, so thank you, everyone, for coming on out. This is
Thank you,
recorded and
everyone.
will be posted. You guys are feel free to watch it after if you want, and whatever. If you want to go back and look at the steps again, feel free to do that. We will post the entire code on GitHub as well. It'll be in the VGDC GitHub, and I'll post a link to that in CSS events, and then you can look at it and do whatever, look at the
And
code.
stay vigilant for more VGDC events in the future.
Yes. And have a great day, everyone. Thank you
Yeah.
so much once again.